Geometric series. So geometric series is different from geometric sequence in what we would be looking for. So for example, I have this geometric sequence. And from number to number, you can see that there's a common ratio, which means there's a common factor that I'm multiplying by. So in this case, each time I move from term to term, I'm multiplying by 2. This is a geometric sequence. If I want to know, and of course this continues, if I want to know the sum of, say, the first 5 terms in the sequence, so then I would be looking at something like this. This is a geometric series. Okay, so the difference is not in the numbers or in the common ratio or any of that, because we still see the same common ratio here that we see up here. The difference is that in a sequence, it's a list of numbers, and for a series, it's a sum. So we're adding them all up. So let's see how we can do some problem solving and find some sums here. And actually, there's a formula that we're going to need. There's 2 formulas. Let me write these 2 formulas on this first page, actually. So there are 2 formulas that we're going to use. Here's the first one. So the sum of the first n terms is the first term minus the first term times r to the nth term over 1 minus r. There's a second formula. It looks very similar, and it is the first term minus the last term that we're looking for times r all over 1 minus r. Now the big difference you can see is that here I'm just using the first term, the common ratio, and then the number that I want. Like if it's the 5th, I want the sum of the first 5 or the sum of the first 7, that would be n. In this formula, I need to know the first term and the last term. So if it's a problem where you're given the first and the last terms, then this would be the formula you'd want to use. If it's a problem where you're just given the first term, the common ratio, and the number term that you want, then you would use the other one. Okay, so the time when you would use this second formula is when you're given the last term, which is a sub n. And then you would use this one the rest of the time. So for this one, we just need to know the first term, the common ratio, and the term we're looking for. Okay, so let's try this. Let's see how this formula works in practice. Find the sum of the geometric sequence, so here's my sequence, when there are 8 terms. So I would need to decide if I'm going to use that first formula or the second one. If I'm looking for the sum of the 8 terms, then I would need to know the 8th term to use the second formula. I don't know the 8th term. So instead, I'm going to use the first formula, which was this one. Okay, so we're going to plug in. Let's figure out what our variables are first. A sub 1 is our first term, so that's going to be 4. R is what we multiply to get from term to term. So 4 times what would give me -8? And -8 times what would give me 16? 16 times what would give me -32? The answer is the same for all 3 of those questions, and it would be -2. So that's our R. And then I'm looking for the sum when there are 8 terms, so that'll be my N. So now we plug everything in. the first term is 4 minus 4 again. And then we have r, which is negative 2, raised to the nth power, which in this problem is 8, all over 1 minus negative 2. Okay, so we simplify. 4 minus 4 times. Well, a negative times a negative equals a positive. So that means that if my power, my exponent, is an even number, remember every time I multiply two negatives I get a positive. So since I'm raising this to the 8th power, it's going to be positive. If you are not sure about that when you're doing these types of problems, you can always do it in your calculator, but beware. If you put negative 2 to the 8th in your calculator without the parentheses, that's not going to mean the same thing as what you've got here. So if you want to know what negative 2 times negative 2 times negative 2, on and on 8 times, if you want to know what that is, you have to be careful and you have to put it inside the parentheses. So negative 2 to the 8th power is 256. 256, and that's over 3. So now we just keep simplifying, and if you're using a scientific calculator, you can put that right in because it'll multiply before it does a subtraction. So that's what I'm going to do. 4 minus 4 times 256 is negative 1,020. And then I'm going to divide by 3. And I get negative 340. So that's my sum for this geometric sequence when there are 8 terms. All right, let's practice with these formulas some more. Find the sum of a 9-term geometric sequence when the first term is 5 and the last term is 32,805. Now here, we know the first term, and we know the last term. And we know that we're looking for the 9th, right, the sum of the first 9 terms. But what we don't have is r. So let's look at our first term and the last term, which is 9. So A1 and A9. To get from A1 to A9, right, I've got A2, A3, A4, A5, A6, A7, A8 in between there, right? So if I want to get from A1 to A9, I have each time, remember, I multiply by that common ratio, and then I'd have to do it again here, 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 here. So I'd have to multiply by r each time I move to the next term. If you count them up, it's going to be 8 hops is what I like to call them because they look like little hops. There's going to be 8 hops in between the first term and the 9th term. So that means I'm going to be multiplying to get from A1 to A9. I'm going to be multiplying by r to the 8th. So now let's look at it in terms of numbers. In terms of the numbers, my A1, my first term is 5, and my 9th term is 32,805. So what would I multiply 5 by to get this? Well, I don't expect you to know that off the top of your head, but we can divide to figure it out. So 32,805 divided by 5. And I got 6,561. So it takes me multiplying by r to the 8th, right, to get from the first to the 9th term. And that's the same as multiplying by 6,561 to get from the first to the 9th term. So that means that r to the 8th is equal to 6,561. The last step to finding r, then, is to do the inverse operation, which would be to take the 8th root of 6,561. All right, so I'm going to do that next. I'm doing that on my calculator. I'm going to take the 8th root, and I got 3. So now I have that r is 3. And that's what I needed in order to be able to use my formula. So because I have the first term and the last term, I'm going to use the other formula, the one that we haven't used yet. So for S, I want the sum of the first 9 terms is going to be, here, let me write the formula first, actually, minus A9 times R over 1 minus R. So now let's plug in. The first term is 5. The 9th term is 32,805. R is 3, all over 1 minus 3. All right, so I'm going to turn to my handy-dandy calculator. And I've got 5 minus 32,805 times 3. And then I'm dividing that number by 2. I got, just so you can check, I got 90 for this top part. I got negative 98,410. And now I'm going to divide that by negative 2. And I get 49,205. So there's my sum. I was able to use this formula because I had the first and last terms, but I needed to find R. And you have to find R to use either formula. So even if I was using the other formula, I'd still have to go through this step of finding R.